So what if I told you we're about to send an AI on a mission that's going to last more than 5 years into the most hostile, unexplored place on our own planet? Well, to survive, that AI can't just be smart. It has to think in a completely new way. Today, we're breaking down the revolutionary AI brain and the incredible deep-sea vehicle that was literally born to pilot it.
Okay, let's just dive right in. Most of the big AI models you hear about today, they use something called chain-of-thought reasoning. And it's really powerful, for sure, but it's also, well, it's linear. It's like a train on a single track. A leads to B, which leads to C. But what happens when a problem isn't a straight line? What if you need to think about your immediate reflexes, your short-term plan, and your long-term strategy all at the exact same time? Suddenly, that one-way street, it becomes a dead end.
So to solve a problem like that, you can't just switch tracks. You have to get off the rails completely. And that brings us to a brand new kind of architecture, one that's designed to break free from that step-by-step processing and instead embrace a model that's way more dynamic, more parallel, and honestly, a lot more like us.
It's called FGSGR, Frequency-Governed Self-Graph Reasoning. It's a mouthful, I know, but the idea behind it is an absolute game-changer. See, instead of a chain, FGSGR creates a graph. Think of it like a web of interconnected thoughts. This lets it explore tons of possibilities all at once, constantly updating its understanding of the world. It's not a train on a track anymore. It's more like an entire city grid of intersecting ideas, all buzzing with activity at the same time.
And the crazy part is, this isn't just some clever bit of coding. It's straight-up biomimicry. I mean, it says right here in the technical specs, the design is inspired by the human brain's cortico-hippocampal circuit. It's actually engineered to copy the way our own minds operate on different frequencies, handling those lightning-fast reflexes and our slow, deliberate planning, all at once.
So how does that actually work in practice? Well, FGSGR runs on what they call a tri-frequency hierarchy. The easiest way to think about it is an AI brain with 3 different speeds of thought, kind of like brainwaves, and they're all running in perfect parallel.
And this is where it gets really cool. The gamma band? That's the AI's nervous system. We're talking millisecond reactions. It's pure split-second reflex, like dodging a rock before your conscious mind even registers it's there. Then you have the alpha/beta band. That's more like focused conscious thought, planning the next few minutes, figuring out how to navigate a tricky canyon. And then there's the theta band. This is the slow, deep hum of strategic awareness, always running in the background, constantly asking, okay, but how does this little maneuver affect my 5-year mission? How's my overall energy budget looking?
Okay, so this all sounds incredible, right? But it brings up one of the biggest questions in all of AI. When you build a mind that's this complex and this free, how do you make sure it stays aligned with its goals? How do you build guardrails into the very nature of its thought process?
And the way they solve this is, well, it's brilliant. See, most AI safety works on what the FGSGR designers call the COP model. It's like a dam. It waits for the AI to come up with a bad idea, and then it blocks it after the fact. It's totally reactive. FGSGR uses the catalyst model. It doesn't build a dam. It actually reshapes the entire landscape. It makes undesirable thoughts energetically unfavorable, so the river of thought just naturally flows in the safe, intended direction. It's proactive, it's elegant, and it's built right into the AI's mind.
So, you've done it. You've engineered this incredible, self-governing, multi-layered AI brain. Now what? Where on earth do you even test something like this? Well, you give it the hardest job imaginable, a job in a place where failure is permanent and rescue is completely impossible. You give it Project Abyssal.
This is it. This is the ultimate proving ground. We're talking about a mission defined by total darkness, by crushing pressure, by absolute isolation, and an operational timeline that isn't measured in hours or days, but in years. If the FGSGR brain can make it here, it can make it anywhere.
Yeah, officially it's called Project Abyssal, the Autonomous Benthic Sensing and Survey Link. But what it is the custom-built body for that FGSGR brain, an autonomous underwater vehicle, or AUV, that's been engineered from the ground up to survive and work all by itself in the deepest, most remote trenches of our oceans.
And when I say extreme, I mean it. Its maximum operating depth is 6,000 meters. That is nearly 4 miles straight down. The pressure there is over 8,700 psi, an absolutely crushing force that would crumple a nuclear submarine like a tin can in an instant.
And it's not just popping down for a quick look.
The target endurance for this thing is over 5 years, with no maintenance, no recharging, and not a single command from the surface. A level of sustained autonomy like this is something we have just never achieved before.
So how does a machine built for a 5-year mission even move? The key is, it doesn't use propellers. The Abyssal vehicle uses a magneto-hydrodynamic drive. Basically, it uses powerful magnetic fields to push water, which means there are 0 external moving parts. And the result? A near-zero acoustic signature. It is, for all intents and purposes, a ghost in the abyss.
I mean, just look at how this thing is put together. The hull is a titanium graphene composite that's 340% stronger than what other deep-sea vehicles use. The propulsion is that silent, totally maintenance-free MHD drive. And its power system? It combines high-density batteries with a thermoelectrical generator that actually recycles its own waste heat back into more energy. Every single piece is optimized for one thing and one thing only: radical long-term survival.
All right, we have the brain, we have the body. Now let's put it all together. Let's actually see how this 3-speed mind pilots this ghost through the eternal night of the deep ocean.
So picture this. The AUV is cruising along, mapping a trench. Suddenly, its sonar picks up an uncharted volcanic vent right in its path. Instantly, that gamma brainwave fires. It's a pure reflex, and the vehicle veers away. That's the nervous system. A split second later, the alpha/beta brainwave kicks in, already recalculating the local survey grid to plot a course around this new obstacle. That's the conscious mind. And all the while, that deep theta brainwave is calmly running in the background, updating the long-term mission plan and just double-checking that this tiny detour won't mess with the vehicle's 5-year energy budget. It's a perfect symphony of thought.
You see, a system this capable is about so much more than just one mission. When you combine a mind like FGS-SGR with a body like Abyssal, you don't just open up the deep ocean, you pretty much unlock a whole new era of autonomy. For science, it means we can finally map the 75% of our own planet's floor that we've never seen in any real detail. Commercially, you could have fleets of these things autonomously monitoring the thousands of miles of undersea cables that basically run the internet. And for national security, well, this represents the dawn of persistent, completely covert undersea surveillance.
And if you're still not convinced, let's talk about the money, because this is where it gets really wild. A traditional survey ship, it costs about $145 to map just 1 square kilometer of seabed. The models for Project Abyssal put that cost at under $9. This isn't just an improvement, it's a complete disruption of the entire industry.
So the big takeaway here is this. What we're looking at isn't just a smarter underwater drone. It's a fundamentally new way of doing things, a new paradigm for how we can interact with the world's most difficult environments. It makes exploration truly persistent, running 24/7, for years on end, completely autonomous, no human in the loop needed, and massively scalable. You could go from one vehicle to an entire fleet.
You know, for its entire existence, the deep ocean has been this vast realm without any witnesses. And now, we are building the minds and the bodies that can finally go there for us and stay for years. When these tireless, silent explorers finally bring a light to the last unknown frontier on our own planet, what secrets about the world are they going to uncover? And what will their very existence teach us about the nature of intelligence itself?